Welcome to Inside Azure. Today, we're unpacking a real-world Azure API Gateway architecture. Roger, you manage APIs at a major tech firm. Can you outline the main building blocks of this architecture and why they're vital for today's digital services?
Absolutely, Tanya. The architecture integrates several Azure components: client applications, TLS offloading, identity providers, a robust API gateway, smart routing and aggregation, backend services, response caching, and comprehensive monitoring. This layered approach ensures security, scalability, and high availability, which are crucial for modern enterprises handling millions of requests.
That's a lot of moving parts. For listeners new to API management, how does Azure's modular approach differ from traditional monolithic API servers? Could you give an analogy for context?
Great question. Think of a monolithic server as a single all-in-one restaurant kitchen, while Azure's modular setup is like a food court. Each stall specializes, ensuring efficiency and flexibility. This separation of concerns means each component can scale or update independently, reducing downtime and bottlenecks.
Let's zoom into the entry point, client applications, and securing those first connections. Roger, can you break down how clients interface with the system and why TLS offloading matters in practice?
Clients, whether they're mobile apps, web dashboards, or IoT device, connect using mutual TLS, which encrypts data and authenticates endpoints. Azure offloads TLS at the edge, centralizing certificate management and improving both latency and security. According to Microsoft, this can reduce handshake times by up to 30% compared to on-premise solutions.
Interesting. Now, authentication is a major concern. How does the identity provider fit into this flow, and what standards are typically used?
Identity providers like Azure AD B2C or any OpenID Connect compliant service handle authentication and authorization. They issue secure tokens after verifying user credentials, allowing the API gateway to enforce access control. This separation adds an extra layer of protection and supports features like multi-factor authentication for sensitive applications.
Given the rise in API attacks, would you recommend multi-factor authentication as a default, even for public APIs?
For APIs handling sensitive or personal data, absolutely. Gartner's 2023 report found that APIs are now the most common attack vector for data breaches, so layered authentication like MFA and token validation is quickly becoming an industry standard.
Now that we've set up a secure entry, let's focus on the API gateway itself. Roger, what makes the API gateway the heart of this architecture, and how does it manage traffic between clients and backend services?
The API gateway is like an air traffic controller. It validates tokens, applies rate limiting, and routes each request to the correct backend microservice. For example, Azure API Management can aggregate data from multiple services into a single response, which is great for mobile apps needing consolidated data quickly.
How does this aggregation actually improve performance or the developer experience? Can you share a real-world scenario?
Sure, imagine a travel app needing hotel, flight, and weather info. Instead of making 3 separate calls, the gateway aggregates those into one response, reducing latency and simplifying the app code. In one case, a customer reduced client-side API calls by 60% after implementing this pattern.
And when it comes to backend services, how do Azure's hosting options like Kubernetes, app services, or functions fit the needs of different workloads?
Azure Kubernetes Service is ideal for scalable, containerized microservices, while app services suit web APIs with predictable loads. Azure Functions shine for event-driven or sporadic tasks, allowing teams to optimize cost and performance by mixing and matching as needed.
Transitioning from operation to optimization, let's talk about response caching and monitoring. Roger, how does Azure handle caching to reduce backend strain and accelerate response times?
Azure API Management supports response caching directly at the gateway, storing frequent responses for quick retrieval. For high-traffic endpoints, this can cut backend calls by up to 80%, slashing latency and infrastructure costs. It's especially beneficial for read-heavy or data lookup APIs.
That's a major efficiency boost. Now, continuous monitoring is non-negotiable for any serious API platform. What observability tools does Azure offer, and how do they help teams maintain reliability?
Azure Monitor and Application Insights provide real-time analytics, tracing requests across components, and auto-detecting anomalies. For example, engineers can spot a spike in failed logins or slow response times instantly, enabling proactive fixes. This tight feedback loop is essential for maintaining SLAs.
Before we wrap up, are there any emerging trends in API monitoring or caching that listeners should keep an eye on?
Absolutely. AI-driven anomaly detection is gaining traction, automatically flagging suspicious patterns without manual thresholds. Also, distributed caching using Azure Redis helps scale performance even further for global apps. Staying current with these innovations will be key for future-proofing API infrastructure.